Rational numbers. First, let us see the definition. A number which can be written in the form of p by q, where p and q are integers and q not equal to 0, is called a rational number. That means any number if we can write in the form of p by q, numerator divided by denominator, such that both numerator and denominator are integers and denominator should not be equal to 0. If they satisfy these two conditions, that number can be called a rational number. Set of rational numbers is denoted by the letter q. Q is for quotient because we are expressing in the form of p by q. We are dividing p by q. The result of division is quotient. That's why we choose the letter q. These are some examples of rational numbers. Let us discuss about each example individually. 5 by 7. This is a rational number. Why? Because numerator is an integer, denominator is also an integer, and denominator is not equal to 0. Therefore, this can be called a rational number. Minus 1 by 2. Numerator is integer, denominator is integer, and denominator is not equal to 0. This number is also called a rational number. Numerator is integer, denominator is integer, but in this case denominator is equal to 0. This is not a rational number. Numerator is an integer, denominator is an integer, and denominator not equal to 0. This is a rational number. Pi. Pi is actually defined as the ratio of circumference to diameter of any circle. You take circle of any size, find its circumference, right here C, find its diameter, right here D, and find their ratio. This will be always a constant for any sized circle. So that constant we are giving the name pi. So you take any circle and try to find the ratio between circumference and diameter. So both circumference and diameter cannot be integers. So this is not a rational number. Pi is not a rational number. Pi does not belong to Q. So it is not a rational number. Every natural number is a rational number. You take a natural number 1. 1 can be written as 1 divided by 1. So numerator is integer, denominator is integer, and denominator is not equal to 0. Or we can also write 2 divided by 2. Numerator is integer, denominator is also integer, and denominator not equal to 0. And so on. We can write so many forms. So because 1 can be written in the form of p by q, where p and q are integers and q not equal to 0, 1 is a rational number. Not only 1, we take any natural number. For example, we take 5. 5 is also a rational number. Why? Because it can be written as 5 by 1, or even we can write 10 by 2, or even we can write minus 15 by minus 3. That's why 5 is also a rational number. So we can decide that every natural number is a rational number. And every whole number is also a rational number. So other than natural number, there is an extra whole number, that is 0. 0 is a rational number or not? Yes. 0 can be written as 0 divided by 1 or 0 divided by 2, etc. If you take this form, numerator is integer, denominator is integer, and denominator is not equal to 0. You can remember one thing. Denominator cannot be 0, but numerator can be 0. That's why 0 is also a rational number. Every integer is a rational number. Let us discuss about some negative numbers like minus 3. Minus 3 is a rational number. Why? Because it can be written as minus 3 divided by 1, or even we can write minus 6 divided by 2, such that both numerator and denominator are integers and denominator is not equal to 0. So minus 3 is a rational number. Like that, any integer you take, it will become a rational number. Every terminating decimal is a rational number. What do you mean by terminating decimal? Any decimal which terminates, that means it has an end. It won't continue forever. For example, we have 2.1. So this can be written as 21 divided by 10. So here numerator and denominator are integers and denominator is not equal to 0. So this is a rational number. We can say 2.1 is a rational number. 1.23. This is a terminating decimal. This can be written as 123 divided by 100. So here also, this is a numerator integer, denominator is integer, and denominator not equal to 0. So this is also a rational number. So we can decide that every terminating decimal is a rational number because they can be written in the form of p by q, where p and q are integers and q not equal to 0. Next, every non-terminating recurring decimal is a rational number. Non-terminating, it should not terminate, it should continue forever. Recurring decimal, a part of the number will be repeated. For example, 0.333 and so on. This can also be written as 0.3 bar. We will learn the method how to convert this into p by q form, but now we will write directly 0.3 bar can be written as 1 by 3. So we can write this number in the form of p by q, where p and q are integers and q not equal to 0. So this number is also a rational number. 1.232323 and so on. This is non-terminating, but it is recurring. Which part is getting repeated? 232323 is getting repeated. So this can be written in bar notation, 1.23 bar. So we'll discuss the method how to write this kind of numbers in p by q form, but I'm writing answer directly now. That is 122 divided by 99. So this is p by q form. Both p and q are integers and q not equal to 0. That's why this is a rational number. We'll take one more example, 0.1232323 and so on. This is also non-terminating and recurring. Again 23 is getting repeated. So this can be written in bar notation, 0.123 bar. Here you note that 1 is outside the bar. So this can be written in the p by q form, 122 divided by 990. How to write in the p by q form we will discuss later. But because we can write in the form of p by q, we can call this number as a rational number. It is a rational number. Every non-terminating, non-recurring decimal is not a rational number. The decimal expansion will not terminate. There will be no end. It will continue forever. But we cannot find any group which is getting repeated. For example, 0.10, 100, 100, and so on. So here they are following one pattern, 1 1 0, 1 2 zeros, 1 3 zeros, etc. So we cannot find any particular group which is getting repeated. So this is non-terminating and non-recurring. Such type of numbers we cannot write in the form of p by q. So this is not a rational number. One more example, 0.123456789101111213. So like this we can continue numbers like this forever. So here also we cannot find any particular group which is getting repeated. So it is non-terminating and non-recurring. Such type of numbers we cannot write in the form of p by q. So this is also not a rational number.